Hey everyone, in this video I'm going to talk about data transformation using dplyr. So dplyr is one of the key members of the tidyverse, so to speak, because it provides very useful tools for a lot of standard data transformation and recoding tasks that you have to do basically on a daily basis, okay? So the key dplyr functions that are available to transform data are filter, which allows you to pick observations by specific values, arrange, which allows you to reorder rows in your data frame, select, which picks variables according to their names in the data frame, mutate, to create new variables with functions of existing variables. So all the recoding that you will do using mutate. And then summarize, which collapses many values from one data frame down to a single summary. Usually we use that in combination with some grouping command. And I'll go through those examples in this video. And one important thing to note and to remember is that all these functions work in a similar way, which is that the first argument in this function is always the underlying data frame. All subsequent arguments describe what to do with that data frame using the variable names in that data frame. And then the result is, again, another data frame. And this is really important because this structure directly allows us to use the pipe and kind of combine these different dplyr functions in a series of data transformation operations. And for this session, we'll use a data frame called flights, or of the NYC Flights 13 package, which is basically a data frame that contains all 300 plus thousand flights that departed from New York City in 2013. And there's a bunch of information on each of these flights, departure time, scheduled departure time, delay, and so on. And we'll use this as a toy example to kind of introduce some of these commands in dplyr. So as I mentioned, the first kind of verb or command in dplyr is filter in order to filter rows. Okay, so here we're starting, and we're immediately starting by using the pipe just to make you kind of get accustomed to that. We're starting with our flights data frame, and we're piping this flights data frame into filter. So this means that flights will be inserted as the first argument of the filter command. And as we remember, each of these dplyr commands uses a data frame as the first argument. Okay. And then we have a logical statement, which is here, which says arrival underscore delay is larger than 120. Or, so this bar is a logical or, departure delay is larger than 120. Okay, so what does this do? It selects all observations for which this logical statement is true, which implies that we will now focus on all flights for that had more than 120 minutes, so more than 2 hours of delay, either in their arrival or in their departure. It could also be both, of course, but it has to be at least one of those. And we'll see that we have 11,000 flights left. And if we look at the departure delay in this column here, okay, of course, some departure delays are not larger than 120 minutes here, but if we saw the arrival delay as well, so for example, for this observation, we would see that it would be larger than 120 minutes, of course. All right, so this is a very quick way to select specific observations and subset your data. And of course, we could now save this subsetted data frame in a new data frame called, flights underscore late or something like that. Right. So one thing that I should maybe note is that, of course, we could do this with base R commands using the brackets as well, and that's probably the way that you're that you've encountered before. The point is that filter in this case doesn't necessarily it doesn't bring new functions to R, just like a lot of other tidyverse functions or tidyverse packages, but it makes some of these tasks a little bit simpler. And using this filter command makes at least the subsetting in many cases a lot more a lot easier to read, and also enables you to directly use the pipe, which is quite useful. The next thing we can do with dplyr is arranging rows using the arrange command. And again, the structure is similar. We start with our flights data frame and then pipe this into the arrange command. And here, what we're going to do is we're going to arrange it by two, just as an example, by two variables. One is month, and I wanted to show you how to arrange in a descending order. So it's descending parenthesis month. And then after arranging flights by month, it's arranging flights by day. So within each month, it's arranging the data frame by day in an ascending order, right? Okay, so the data frame that we see is, of course, the complete data frame, flights with 336 plus, or 336,776 observations. Now with month, of course, starting in December and starting December 1st, essentially. We can also select specific columns in our data frame using the select command. For example, here we're just selecting two variables, departure time and scheduled departure time. And the result of this operation is, again, a new data frame, which now has only those remaining two variables that we're interested in. And again, we could save this now as a new object if we wanted to keep it, for example. We can also, and this is kind of the most important part when it comes to data transformation, we can add new variables with Mutate. And Mutate works in a way where, again, we pipe a data frame into the Mutate command, and then we can create a new variable by, maybe I should say first, one thing I'm doing here is I'm selecting some variables that are that are going to be interesting for me. So I'm going to select first year : day, which means basically all variable names between year and day. So that's year, month, and day. I'm also keeping, and there are a couple of helper functions that are useful if you want to select specific patterns of variables. So here I'm selecting all variables that end with delay. So that includes departure delay, departure underscore delay, and arrival underscore delay, those two variables here. And then we'll also keep distance and air underscore time. So how much of a distance the flight took and how long they have been in the air. Okay. So the first argument is just selecting those variables, and then we're again using the pipe and then the mutate command. And now we're creating two new variables. One is called gain, which we basically just compute the difference between the departure delay and the arrival delay, so to what extent they were able to make up their delay. And we also include a new variable, or create a new variable called speed, which is just the distance traveled divided by the air time times 60. Okay, and all of this is now saved, as you can see here, flights underscore SML. We create a new data frame that basically is based on the original flights data, and where we went through all these different transformations and selections. And if we call this data frame, we'll see we have a new data frame. It's still the same number of observations, but a smaller set of variables, of course, because of the select command. And we have two new columns, gain and speed, that are right here, that contain our information about how much time they gained between departure and arrival, and the speed of the aircraft. In some cases, one thing to keep in mind is that Mutate always takes a data frame and creates new variables and adds those variables to the old data frame. That's not always the behavior that we want. Sometimes we just want to create new variables, but we don't care about the old variables and kind of want to discard them. And of course, we could use select after the mutate command to achieve that, but there's actually a shortcut, which is transmute. Transmute works similarly to mutate. The only difference is that the data frame that transmute creates does not, or only contains the variables that are created in the transmute command and discards all the other old variables. So in this command, we again start with flights, pipe this into transmute, and then we create three variables, gain and hours, hours or airtime divided by 60, and then gain per hour is equal to gain divided by hours. So how much time they gained per hour on average. And note here, one quick thing to note is that in our transmute call, we can directly include variables that have been created previously in that same transmute command, right? So we're using transmute, we're creating the variable gain, we're creating the variable hours, and then we can immediately create a third variable, gain per hour, that is based on these two variables that we previously created, okay? And the output of that set of commands is again a data frame that now only consists of those three variables that we created with transmute. The last data transformation and operation we can do, or that I want to talk about, is summarize, which allows us to create grouped summaries of variables, okay? And so there are two steps in this command. Usually what we want to do is we want to take our data frame and we want to group it by some variable. In this case, we want to group by three variables, year, month, and day. We could technically, in this case, since all flights left in 2013, we could omit year. But we'll just go with this for now. After declaring the grouping in the data frame, we use the summarize call and as the next part in the pipe to create a variable called delay. And delay will be the average departure delay based on that grouping. So what summarize now does is it takes the grouping. So basically it takes the flights in each day. So by combining month and day, each group is basically a unique day in the year of 2013. So for each unique day in all flights that departed on January 1st, for example, we compute the mean of departure delays and then create a new data frame that saves that for each individual group. Okay. So that means, of course, that the resulting data frame is much smaller than the original data frame. It only has 365 observations, of course, for every day of the year, and 4 different variables. The 4 different variables are the first 3 are the grouping variables, year, month, and day. And delay is the new variable we created, which is the average delay, or departure delay, I should say, for each of those days in 2013. Note also that, and I'll show you this in the next example, that you can create multiple summaries in one summarize call. So here's another example. It's the same structure where we create multiple summaries. Again, we start with the flight data. This time we're grouping it by destination, so where the airplane was headed. We're summarizing we're creating three different variables as part of our summarize call. First, we create a count variable using n parentheses. This will just kind of give us information about how many flights belong to each group, which is useful with every summary call that you will do. It's often useful to just include the count just to give you some information of how large the groups are. Then we have the average distance within, so the average distance that flights that went to each destination took, and then the average delay, of course, okay? And again, the underlying or the resulting data set is, again, a tibble or data frame with 105 observations, so 105 unique destinations that are here, with now three different variables, three different summaries that we created. One is the count, just how many flights landed at that specific destination, the distance they traveled, and the average delay. Okay? And one thing that is nice is specifically using the pipe, which we've done the entire time, is we can combine these different dplyr commands, but we can also combine it with the ggplot if we want. Of course, we could save this data that we created here in a new object, and then go on to, for example, plotting that. But since the outcome or the output of these sets of functions is always a data frame, and the first argument in a ggplot command is also a data frame, we can also directly pipe this to a ggplot command if we want to, for example, plot the relationship between the average distance that we computed and the average delay. And just for fun, to give you an example here, we filtered this plot by only including, after computing the summary, we're filtering out observations that have fewer than 20 or less arrivals. So it's very small airports are excluded. And we're excluding H&L as a destination. And then we're directly piping the result of this set of commands into ggplot, where we then specify the aesthetic mapping, where distance is mapped onto the x-axis and y is mapped onto the delay is mapped onto the y-axis. Then in the next stage, we add a geometry point where we add an additional aesthetic mapping where size is mapped onto the count. So the point size will now be dependent on how many planes arrive at that specific airport. And we will make these points slightly transparent so that overlapping points can be distinguished. And then we're adding an additional geometry, which is, again, a smoothed lowest fit, but this time without including the confidence interval. Okay? So you should already have a good idea of how this plot is going to look like, but here's ultimately the result. Again, we have on the x-axis, we have the distance that the airplane took to get to that specific destination. We have the delay on the y-axis. Each dot is now a unique destination. The size of each dot identifies how many planes arrived there in 2013. And we have a local average fit looking at the relationship between distance and delay. And we see that for very close airports, delay is lower, it increases, but then for very large distances, the average delay decreases again. So the longer the distances the plane has to kind of cover, the more time there is to kind of make up the initial delay. And that would be one potential interpretation. All right, that was the introduction of data transformation using dplyr, and in the next video I'm going to talk about importing data.